This video is going to talk about ratios in the coordinate systems. To create a ratio table, remember that we multiply by both numbers in the first row, which is the given ratio, by the same number to produce the next row. Usually we multiply by the numbers in an order, by 2, by 3, by 4. So you see the ratio here of 1 to 3. When we multiply both sides by 2, that's when you get 2 to 6. When you go back to the original and multiply by 3, that's when you get 3 to 9. And then by 4. So they want us to produce a ratio table for the given ratios. So we have the ratio 2 to 3. Now when I multiply 2 and 3 by 2 on both sides, 2 times 2 is 4, 3 times 2 is 6. When I multiply both sides by 3, 3 times 3 is 9, 2 times 3 is 6. And then when I multiply both sides by 4, 2 times 4 is 8, 3 times 4 is 12. We're going to do the same thing for 4 to 5. You go ahead and try, and then we'll talk about it. Welcome back. Starting with 4 to 5, multiplying each side by 2, you would have gotten 8 to 10. And then 12 to 15, and then 16 to 20. Go ahead and try 5 to 3, and then we'll talk about it. Welcome back. So for 5 to 3, you would have gotten 10 to 6, 15 to 9, 20 to 12. You may have gotten other numbers as you do this. If you didn't multiply by 2, and then by 3, and then by 4, you would have found that you got different numbers. So long as they all simplify back down to that 5 to 3, then you're good to go. 2 to 1, we would do the same thing. You would get 4 to 2, 6 to 3, and 8 to 4. Now, is 1 to 3 the same as the ratio 3 to 1? Let's take a look. If we look at the ratios as a fraction form, we see that the ratio 1 to 3 equals 1/3. The ratio 3 to 1 equals the fraction 3 ones, or 3 wholes. 1/3 is very different than 3 wholes. If we have 2 colors of paint, red and yellow, and we mix 3 cups red paint to 1 cup yellow, we get dark orange. If we mix only 1 cup of red paint to 3 cups of yellow, then we get a light orange. That changes because it depends on which one you have more of, which is why we have to make sure that we follow the ratio and we follow the order. So red to yellow is very different from red to yellow if you're not careful about how you place those numbers. Note how those numbers in the ratio are different. We can create an ordered pair from each ratio. That's the points that we graph on the coordinate plane. Then we can draw a point on the grid, so the ordered pair is the coordinates of that point. The ordered pairs that we're going to draw, that we're going to write right now, they don't take any extra thing to do. It's just taking 1, 3. Well, that becomes 1, 3. And you can see that I have parentheses around my ordered pair, and I have a comma separating the x and the y number. you go ahead and create the rest of the ordered pairs, and then we'll talk about it. Welcome back. You should have also gotten 2 to 6, 3, 9 with a comma, and 4, 12. Those are the ordered pairs that you should have gotten. So to plot, remember that the first number in an ordered pair is the X, or the run. The second number in that ordered pair is the Y, or the jump. So we have the X column and the Y column. So they want us to draw a coordinate grid and plot the point 1, 3. Excuse me. So at the corner, that's always going to start at 0. Our x-axis is going to go this way. That's our first number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going up and down, that is our y coordinate, or our jump. So if I want to plot the point 1, 3, I'm going to start at 0, and I'm going to run 1 space, and then I'm going to jump 3 spaces. And that is going to be where my point is. So let's go ahead and let's plot that 1, 3 on here. So start at 0, go to 1, jump 3. There's my first point. Then I'm going to plot the rest of the points from that other page. 2, 6, 3, 9, and 4, 12. I can run 4, but there's no 12 on here, so I'm going to have to give my best estimate. 10, 11, 12. Now, what do you notice about these lines right here? These lines, it's going to be really hard to show on the computer, but these all line up. These points all line up in a straight line. And you can see how they all fall on that same line. And that confirms that these are from a ratio table. They're all the same ratio. Excuse me. So when they want to extend the lines towards the origin, we see that it does reach 0, 0, which also helps us understand what's going on here and that it is a ratio. Nope, backwards. So remember that the point at 0, 0 is the origin. Each row in a ratio table is created by multiplying the first row of the ratio table by the same number on both sides. What number could we multiply the first row of the ratio table by to get 2 zeros? Multiply by 0. But 0, 0 is not a ratio because it doesn't simplify, and it's not something that you can multiply another number. So I can't multiply 0, 0 by 2 on the same side and get the same ratio from the ratio table, because anything times 0 is 0. So instead, excuse me, this is an early morning video. So instead, the ratio table has to pass through the origin, but all ratio tables should do that. Can we write 0, 0 as a fraction? No, because you can't have 0 parts of nothing. Points produced by ratio tables fall on the same line, and that line passes through the origin. These are the facts that can be used to check whether a table is a ratio table. So, for example, we have these points. 1, 1, 2, 3, 3, 7, 4, 13. Let's go ahead and put this on the ratio table. What I would like you to do is I would like you to copy these down. I'm going to take a quick picture so that we can go back and put them on that same ratio table from all the way back here, because this is the ratio table that I have. What slide is this? 13. So let's go ahead and on page 13, the computer is going to behave and is going to help me to delete everything that I had on here. So we can go ahead, let's graph 0.11, let's graph 0.23, let's graph 0.37, and 0.413. You can see that these do not create a straight line. They don't connect up with each other. And if I were to try to follow this, it would be more of a curve. This is not a ratio table. Going back to look at the other numbers, 1, 1, 2, 4, 3, 7, 4, 10. When I put 1, 1 on the ratio table, and then I put 2, 4 on the ratio table, I would expect this line, first of all, to be able to pass through the origin, and it won't. I would also expect it to connect up to the next number if it was indeed a ratio. But what I'm doing instead is I see that 3, 7 is right here. I see that 4, 10 is right here, so it looks like it's getting close to a line, but it does not pass through the ratio, through the origin. And I would also see, actually the only thing is that it doesn't pass through the origin. It's difficult to tell on here, but that does create a mostly straight line. Not a completely straight line, but a mostly straight line, which is why we typically work with rulers. But the situation. So they want you to make a list of ordered pairs for the ratio table. So let's go ahead and then they want you to join them up. So there are 3 here. So you go ahead and create the list. We see 1 to 1. We see 2 to 3. I see 3 to 7, and I see 4 to 13. Those are the points, but I can see that 1 times 2 is 2, but 1 times 2 is not 3. I also don't know what 3 times 7 is. So I know right off the bat, this is not a ratio table. Let's take a look at the next 2. Now I'm going to have to go ahead to take a picture of the points again. And let's go ahead and let's take a look at our good old trusty ratio table. So the first point was 1, 1. And I can see the point there. And then it was 2, 4. And then we had 3, 7. And then we had 4, 10. And I can see that while these do make a line, that line does not pass through the origin. So that is not a ratio table. For the last one that we had on that page, two, 2, 4, 5. I'm going to go ahead and graph 2, 2. I'll go ahead and find 4, 5, 6, 8, and 8, 11. And I can see that these don't even make straight lines here, which is not at all helpful for a ratio table. So this would also not be a ratio table. Ladies and gentlemen, I hope that you have an absolutely fantastic day.